Hey guys, what's up? So this is more on adding and subtracting fractions. So in this video, we're going to be looking at more problems like this and just everything that goes into like evaluating them, I guess. So this is part 2 in a 2-part series. So if you feel like this is too much, I highly recommend that you go back and watch part 1, just because you might need to brush up on some of the foundational ideas that go into fractions, which I'm assuming you kind of already know if you're watching this. Okay, so when you want to add or subtract fractions with different denominators, there are 3 things that you have to do. First, you have to find the least common denominator between the fractions. Then you want to rewrite the fractions with the new denominator. That's your desired denominator from part 1. And then after that, you can add or subtract. And we talked about just, when you have the same denominator, how do you do that? We talked about that in the last video. So first, let's focus on the least common denominator, which going forward, I'm going to call the LCD. So I'm going to give a pair of fractions, and I'm going to kind of walk you through how to do this and all the reasoning that goes into this. And all we want to do right now is just find the LCD, because once you know this, you're almost there to kind of finishing the problem. So here's what I want to notice. What is the largest number that will divide both 6 and 10? You might want to pause the video and think about it for a second. In this case, it would be 2. 2 divides 6 and it divides 10. So that's what you're looking for. It's the same number that will divide both. Now, what I want to do is I want to show you how to factor each one of these numbers using that commonality. So in this case, this is going to look kind of simple, and then I'm going to show you a more complicated case of this in a moment. So just kind of go with me here for a moment. So for 6, so like I said, 2 divides each one of these. So 6 I can rewrite as 2 times 3. And then for 10, I can rewrite 10 as 2 times 5. So again, if you're kind of not totally sure about this, just hold on. We're going to do 2 examples, then I think you'll get the whole idea behind this. All right. So with that in mind, using those factorizations, 6 is 2 times 3 and 10 is 2 times 5, now we can actually find the LCD. So the thing to notice is that thing that they had in common, that goes into the LCD once. So they both had that 2 in common. You write that down first for finding your LCD. And then the 2 things that they don't have in common, i.e. they don't have the 3 and they don't have the 5 in common, you also write those down as well. So you have 2 times 3 times 5. That's everything together, and that's going to equal 30. So again, that 2 will be the commonality that divides both numbers. And then these other numbers that they don't share, those all go into the LCD. So that's kind of how we do it. All right. So the LCD here is 30. We're good to go. I want to jump into another example just to really show you kind of how this works. So now I've got 1 over 12 and 1 over 18, and I want to find the LCD. So what is the largest number that will divide both 12 and 18? Make sure it's the largest. So you might have to pause and think about this for a second. The largest number that will divide both is 6. So notice if you chose either 2 or 3, so 2 divides both 2 divides both 12 and 18, and 3 divides both 12 and 18, but that's not the largest number. The largest number that you can divide both at the same time by would be 6. That's really what we're looking for to get to our LCD. Okay, so now I want to do that same process. Show how to factor each number using that number. So it's a little redundant language. Let me show you what I mean. So for 12, so like I said, the biggest number that divides into both of these, 12 and 18, is 6. So I want to rewrite 12 as a product of 6 times something, which in this case 12 will be 6 times 2. Now, how would I write out 18? How would I do this? I want to use 6 as part of my factorization. So 18 would be 6 times what? 18 would be 6 times 3. So here's kind of the way that you want to think about this. Okay, so now that we have these factorizations, now we can go into what the LCD actually is. So here are my 2 factorizations. I'm going to pick out the LCD. Now remember, we talked about that number that they have in common, that's 6, that goes into the LCD. And now look at what's not in common. So this 2 and this 3, these are also going to go into the LCD, like this. So it's going to be 6 times 2 times 3. And then if you multiply all of that together, you're going to get to 36. So this is the idea actually behind finding the LCD. This is kind of like the most efficient manner to do it. I know that there's a lot of different methods for this. So I do want to note, there is more than one way to find the LCD. And sometimes people get frustrated and they say, oh, I don't want to learn it like this. I learned it my one way and that's the only way that I can learn it. But I want to push you to expand your mind a little bit. So the reason why I use my method is because it will be similar reasoning in other applications for higher math classes. So if you change your way of thinking about the LCD as finding common factors, you can actually see that this idea will be extended in other math classes. So this reasoning can extend through intermediate algebra, pre-calculus, even parts of calculus. It's kind of all the same stuff. So this is why I teach it like this, because I think you can build off of this one idea. So that's why I like to teach it like this. Okay, so now what I want to do is I want to have you try finding the LCD in this case. So I will walk you through this if you want. So the first thing that you want to do is you just want to think about what number divides 28 and 42 at the same time. And then write out each of those numbers factored like that. So you can pause here and then hit play when you're ready to see that. Okay, so for 28 and 42, the largest number that will divide both is actually 14. So I take 28 and I write this out as 14 times 2. And then I take 42 and I write this out as 14 times 3. Now, what if you just chose 7? If you chose a different number, I will show you what happens later. So let's go through with choosing 14 to start, and then I'll just show you what happened if you did something else. So for my LCD, we've got that 14 in common. So my LCD is going to be 14, and then what? Times 2 times 3. And if you multiply those together, that will be 84. Okay, so let's back up here. Let me get rid of all of this. So what if I thought that 7 was the largest number that went into one of these, or into both of these? So I rewrote 28 as 7 times 4, and I wrote 42 as 7, is it equals? 42 equals 7 times 6. You can actually tell just by looking at this. So notice that the 4 and the 6, these actually still have a commonality in them, right? These can both be divisible by 2. So that's a hint that you did not choose the largest number. So if you go this route, you will still get to a common denominator. You just won't get to the smallest one. And sometimes when you choose a number that's too big, it makes kind of multiplying everything together just a little bit more hard. And then also you're going to have to simplify at the end. So you do end up creating a little bit extra work for yourself if you don't choose the number. So if I went through with this though, notice I could totally finish my LCD process. So I could say, oh, my LCD is 7 times 4 times 6. And that's equal to 168. So it's a much larger number. It's actually double the denominator that we found before. And that's because we are basically like this 4 and this 2, they both share a factor of 2. They're both divisible by 2. So we are basically like putting an extra factor of 2 into this. So you just make it a little bit harder for yourself. And I will show you some more examples of that coming up. It's not wrong. It's just, different way makes it slightly harder. And sometimes it'll happen, so it's not a big deal. Okay, so one more here. Go ahead and pause the video. Go ahead and find the whole LCD and then hit play when you're ready. So for this one, so the largest number that divides into both would be 6. So I can rewrite 24 as 6 times 4, and I can write 42 as 6 times 7. So notice I can tell that I chose the right number because between 4 and 7, there's nothing that divides both of these at the same time except for 1. That's kind of the relationship that you're looking for. So in this case, my LCD, I'm going to write these 6's. So this is going to be 6 times 4 times 7. We just did that calculation, so this is still 168. So that would be the LCD in this case. Okay, so now that we've got the LCD down, now I want to pivot to what happens with addition and subtraction. So if you've got a addition or subtraction problem, of course, the first thing that you're going to want to do is find the LCD. So in this case, between 12 and 15, the largest number that would divide both would be 3. So I'm going to write this out. 12 is 3 times 4, and 15 is 3 times 5. So I notice here that the 3 is in common. So my LCD will be that 3, and then, so this 3 here, and then times the 4 and the 5. Okay, so there's my LCD, 3 times 4 times 5. And if I multiply all those together, I get that that's 60. Okay, so now we need to rewrite each fraction. I basically want this fraction and this fraction to have this denominator of 60. That is the goal. So starting with 1/12, here's what you want to think about. What do you multiply 12 by to get to 60? What would you have to multiply that by? In this case, it would be 5. So that's what I want to multiply the top and bottom of this fraction by. So we're going to multiply that by 5 over 5. And so there we go. So I'm multiplying 5 over 5. If I do that and multiply everything together, I get 5 over 60. So that's what I'm going to replace 1/12 with 5 over 60. Now, I do want to point out here, there is another way to do this. So if that explanation didn't work for you, try this one. You can think about 12 actually in a more visual way. So remember, this 12 we wrote as this factorization up here. So I could revisualize this fraction like this. I could think of this as 1/12. This is the same thing as 1 over 3 times 4. 3 times 4 is 12. Okay, so now here's what you do. You want to compare this with this. So what you're thinking of then is, what does this LCD have that this factorization does not? And you can see then just by comparing the two that it's the 5, right? This has this extra 5 here. So that 5 right there, that's exactly what I want to multiply by then. So I multiply that missing factor as shown, and we get to the exact same answer, right? It's still 5 over 60. So some people will just think about it as, well, what do I multiply 12 by to get to 60? But other people will use all of this work up here actually as a map to help them figure out what to multiply by. So if you find that you're getting stuck, you don't know what you're supposed to multiply by, that's the whole point of doing all of this work up here. If I say I don't know what to multiply 12 by to get to 60, you do if you think about just all this. I know that 12 is 3 times 4, and I know that my LCD is 3 times 4 times 5. So what does this have that this does not? This has this extra 5. That's exactly what I'm going to multiply by. Okay, so anyways, we know now that this is going to be 1/12 is equal to 5 over 60, however you want to think about that. So now let's move on to this 4/15. So two different ways you can think about this. Either what do you multiply 15 by to get to 60? Or if I look at how this is kind of multiplied together, this was 3 times 5, and the LCD is 3 times 4 times 5. Either way, what do I have to multiply this guy by to get to 60? In both cases, you have to multiply it by 4 over 4. And if you multiply all that together, you'll get 16 over 60 as shown. Okay, so now I've got the two pieces that I need. These two fractions are equivalent to these two fractions. So now what I'm going to do is I'm going to rewrite these two fractions as this new problem. So let's clear out all the other work. Okay, so now I'm exactly where I need to be. And remember, we said that this was the whole goal in the first video. Now that I've got this, I can just add the two top pieces together and I'm good to go. So this is going to be 21 over 60 because 5 plus 16 is 21. So once you get to this step, which can be a little bit of work, but once you get to this, it's nice and straightforward. Now, 21 over 60, now that I think about this, I notice I can divide the top and bottom by 3. And so this will simplify to 7 over 20. So a note on this. You cannot simplify until you have finished adding or subtracting. So I can't do this step until I'm at the very end. So I can't start like trying to cross multiply or anything like that. Some people think of that because it's, you know, with multiplication and division, you can cancel out common factors, but it doesn't work like that for addition and subtraction. They're two different beasts. Okay, so let's take a look at another one here. Let's maybe work on this one together. So I've got 3/10 plus 2/15. First things first, what's the LCD? Maybe you want to pause here and then hit play when you're ready. So in this case, what divides both 10 and 15? It would be 5. So 10 is 2 times 5. 15 is 3 times 5. So they both have this 5 in common. So my LCD is going to be that 5 that they have in common times 2 times 3. And I know that that equals 30. Okay, so now what I want to do is I want to make my equivalent fractions. So what I want you to think about here is, what do you have to multiply 3/10 by to get to this denominator of 30? Well, in this case, you want to multiply the top and bottom by 3. So if I do that, then I'm going to get 9 over 30. So 3 times 3 is 9. 10 times 3 is 30. So bada bing, bada boom. Okay, so what about 2/15? What do I want to multiply that by? So what do I have to multiply 15 by to get to 30? Again, if you're not sure, you can just compare this factorization, 3 times 5. Compare it against the LCD, 5 times 2 times 3. So basically, what does this have that this doesn't have? It has that 2, so I'm going to multiply by 2 over 2. 2 times 2 is 4. 15 times 2 is 30. So now we've got everything that we need. We've got our two fractions. So what I can do now is I can rewrite this step now using this fraction and this fraction. So that's going to look like this. So now this is 9 over 30 plus 4 over 30. So then I can go ahead and I can add those together to get 13 over 30. I can't simplify any farther, so we're actually done with this one. Now, I do want to show you another way to do your work. If looking at all of that, you don't like that, you want to like have maybe a faster way to do it, there is another way. So re-examining this problem, there's all my work for the LCD. I already found it, so I've got that kind of noted. So here's another way that you can think about this. You can start by doing, so 3 over 10, we already talked about this, right? So I have to multiply the top and bottom here by 3 over 3. And then I can just continue on with this problem. So notice I'm kind of just taking this and I'm expanding it. So what do I multiply 2 over 15 by? We already talked about that. We multiply that by 2 over 2. So notice I've just taken this line and now I've just expanded it and kind of put in all the work to get to those denominators. I've just put it straight in the problem. And from here, now I can just work on this piece by piece. So I can multiply this part together, which I know if I multiply this part together, that's going to be 9 over 30. And then I can pivot and take a look at this other part, multiply that stuff together to get this. So some people prefer just doing all of this together. And if you like that explanation, go for it. And then you just finish it the same way. So it's all good to go. So it's important to do your work in a way that you can keep track of. So the first way that I've been showing, for some people that really resonates, and for other people, they really don't like it. And the second way I just showed, like doing all of it together, makes a lot more sense. So you really want to make sure that when you are approaching something complicated like fractions, you are taking the way that you do your work very seriously, actually. You can learn quite a bit about yourself and how you best organize information and sort out problems from how you best do your work. So you want to be cognitive of how you write things down and how you keep track of things. One way might not work for you, another way might. If you get confused in the middle of a problem, consider trying to do your work in a different way. That's kind of the big point I want to make here. So I've shown you two different ways. Try to find the way that works best for you. Okay, so let's do one more of these together. So I've got 1 over 24 minus 3 over 18. So let's start by finding the LCD. If you want to pause and find the LCD, go for it. So I'm thinking about what divides into 24 and 18 at the same time. That would be 6. So I want to rewrite both of these numbers now utilizing that 6. So 24 is going to be 6 times 4. 18 is going to be 6 times 3. So that 6 is exactly what we just said that they have in common. So to get to the LCD, I'm going to take this 6 times 4 times 3, and that comes out to 72. Okay. From here, I want you to pause and finish this problem, but I want to challenge you to show your work neatly and clearly. Judge yourself on how you've presented your work and if you can easily read it and find mistakes in it. If not, think about doing your work in a different way. It's totally fine if you're not getting to the right answer. Like if you're not getting to the right answer, that's something that we can work with. But if you can't get to the right answer because you're struggling with how you present your work and you're having trouble reading it, that's a different problem, right? Those are two separate problems. So I highly recommend just making sure if you're going to practice this to just take your time with this. Hit play when you're ready. Okay, so I'm going to continue on with the problem now. So 1 over 24, I want to rewrite this now with that denominator of 72. So I need to multiply this fraction by 3 over 3. And then for the 3 over 18, I need to multiply that by 4 over 4. So now I can multiply these things together. So multiplying this first part together, so 1 times 3 and 24 times 3, that's going to give me 3 over 72. And then I will jump to the next part of this, multiply those pieces together. So 3 times 4 and 18 times 4, this is going to give me 12 over 72. So now I can finish the math here. 3 minus 12 is negative 9, so this is negative 9 over 72. And then notice from here, I can actually divide the top and bottom by 9, so this all simplifies to negative 1/8. So that covers the basic mechanics and idea behind this. So do you want to see more examples? If you are in that boat where you want to see more, I have more guided examples. Look for a link in the description of this video. And I have a lot more examples where I just kind of build out how to continue this process that you can practice if you want to see more. But otherwise, I'm going to leave this video at that. It's around 20 minutes. That's about where I like to cap them. And if you want to see more, I'll see you guys in the next video. Thanks for watching.